So today what we are going to look at is an example of what we were discussing yesterday when it comes to adding vectors using components. And we're going to create a table of these components, work them out, and proceed to work out the resultants, the different resultants which we need to work out. So what do we have? So here we have got three vectors. So consider vectors A, B, and C, which have magnitudes 20 meters, 30 meters, and 10 meters respectively. So vector A is 20 meters, vector B is 30 meters in size, vector C is 10 meters in size. The vector A makes 45 degrees angle anti-clockwise from the positive x-axis. So the angle between the positive x-axis and vector A is 45 degrees. The vector B makes a 120 degrees angle anti-clockwise with the positive x-axis. So the angle between vector B and the positive x-axis is 120. Vector C lies along the negative x-axis. So vector C lies along the negative x-axis, which is an angle of, if something lies along the negative x-axis, as we are going to see, then the angle must be 180 degrees. So here we have our xy plane. So this bit is our positive x-axis. If I can try to maximize it a bit. So this bit is our positive x-axis. This is a positive x-axis. Then this end is the negative x-axis. So you have to choose which axis is going to be which. So here's the positive x-axis. Then this is negative x-axis. Then the positive y-axis on top. The negative y-axis on top. So we have got vector A, this black line. The size of A, vector A, is 20 meters, and the angle it makes with the positive x-axis is 45 degrees. Then we have vector B. The size of vector B is 30 meters. So these are displacements, and the angle it makes is 120 degrees. Then you have got vector C, which has got a size of 10 meters, and the angle it makes with the positive x-axis is 180 degrees because it lies along the negative x-axis. So basically, these are our vectors. These are our three vectors with their respective sizes or magnitudes and directions. With this information, armed with this information of each vector, what is its size and the angle it makes with the positive x-axis, or in other words, direction, we can work out how much each of these vectors are along the x-axis and along the y-axis. So basically, we can find out how much each vector is along the x-axis and along the y-axis by working out the components of each of these vectors. And that is what we are going to do next in this table somewhere here. So in this table here. So we have vector A, this one. So the x component of vector A is how much vector A is along the x-axis. So what do we know about vector A? We know that the size of vector A is 20 meters and the angle it makes with the positive x-axis is 45 degrees. So AX is 20 meters multiplied by cos 45 degrees. That gives us approximately 14 meters. That's how much vector A is along the x-axis. Then vector A along the y-axis, so we work out the y component again. The size of vector A, 20 meters multiplied by the sine of the angle between vector A and the x-axis. So this gives us another 14 meters. Are we clear on the calculation of the components of A, AX, and AY?
Yes, sir.
Yes, sir.
Okay. Next, we move on to vector B. So for each of these vectors, we find out how much each vector is along the x-axis and how much it is along the y-axis. So we move on to vector B, and we're working out Bx. So Bx is equal to the size of vector B. Vector B is 30 meters, and the angle it makes to the positive x-axis multiplied by the cosine of the angle. The angle is 120. So 30 meters times cos 120. That gives you minus 15 meters. So here we have an example of a component which has got a negative sign. So this component Bx is minus 15 meters. What does that mean? We are talking about the x-axis. It means that it is pointing in the negative direction of the x-axis. So this bx actually points in the negative part. It points this side, this negative part. So it lies along this line, this end for bx. So in the x direction, the vector b is a component along the x, lies along the negative part. That's why you've got that negative sign there. Are we clear? Then for by is 30 meters multiplied by, that's the size of the vector, 30 meters, then multiplied by the sine of the angle, which is 26 meters. This 26 meters is positive. So the bx is negative, then the by is positive, 26 meters. What this means is that the y component of this vector b along the y component lies along this line. It's positive. For vector a, both of them are 14 meters. So the ax is 14 meters, it's positive, so it lies along this line. Then ay is another 14 meters, it lies along that line. That's why the components are positive. Ax is 14 meters, so it's positive component. Then ay is 14 meters. In the case of vector b, ax is minus 15 meters, telling you that this vector, this component lies along the negative end of the xy plane, along the negative x direction. Then by is 26 meters. It means that this vector, this component or this scalar lies along the positive y-axis. Then we move on to vector c. Vector c has got a size. We want to find cx, which is how much is c along the x-axis. So c has a size of 10 meters, and the angle c makes with the positive x-axis is an angle of 180 degrees. So we multiply 10 meters times cosine 180 degrees. This gives us minus 10 meters. Again, here is a component which is negative. So this tells you that cx lies along the negative x-axis. The interesting bit here is that cx, this negative 10 meters, is the same size as vector c. For the rest of these other ones, the size is less than the size of the vector. This one was 20 meters, but the component is 14. 20 meters, 14. Here, the vector is 30 meters, the component is half of that. Then here is 30 meters, the component is 26. Then here we have a vector whose size is 10 meters, and its component is minus 10 meters. This has got consequences. So if you work out cy here, cy is equal to 10 meters multiplied by the sine of the angle. The angle is 180 degrees. So sine 180 degrees, that gives you 0. 0 multiplied by 10 meters, you get 0. So vector c does not have a y component. Vector c only has an x component, which is negative 10 meters. This x component lies along the negative x-axis, and you can see why vector c does not have an x component, because it just lies along. This is c, this is vector c, size 10 meters, lying along the negative x-axis. There is no part of this vector c which lies along the y-axis. There's nothing, because of the angle it makes. It makes an angle of 180 degrees. Are we clear on how you break each of these vectors, or how you decompose each of these vectors into its component? Ax, ay, bx, by, cx, cy. Are we clear?
Yes, sir.
Okay. And on the meaning of a negative, if a component has got a negative sign, it means that it's pointing in the negative direction, lying along that axis but pointing in the negative direction. So in this case here, we want to work out the resultant we want to find is a plus b. So how are we going to find a plus b? So for us to work out a plus b, we first need to add the components of a together. So in this case, the x components. So ax plus bx. That's what we need to do. We need to work out this ax plus bx. So how much is ax? Ax is 14 meters. 14 meters plus bx is minus 15 meters. So 14 meters plus minus 15 meters, you get yourself 1 meter. Is that clear? So you're seeing the effects of the direction. So 14 meters plus 15 meters, you get yourself 1 meter. This means that the x component of a plus b is pointing in the negative x direction because it has got a negative sign and it is 1 meter. Then you work out the y component. This is ay plus by. Ay is this one, 14 meters plus by is 26 meters. So 14 meters plus 26 meters, you get yourself 40 meters. Next, a minus b. So we want to find for each of these, we want to find what is the size of this resultant or this vector combination along the x-axis, what is the size along the y-axis. So we move on to a minus b. So a minus b, for us to work out a minus b, is going to be ax minus bx. So ax is 14 meters, then we put a minus, then bx is minus 15 meters. So what we have is 14 meters minus 15 meters, and that gives us 29 meters. Is that clear? 14 meters minus 15 meters, we get 29 meters. So you've got two negatives. So when they do that, it becomes a positive. Is that clear?
Yes, sir.
Next,
yes, sir.
We move on to... Sorry?
Sir, repeat what you just
Yes, sir.
sir.
Here, a minus b. A minus b, we need to find out how much a minus b is along the x-axis. And that, how do we get that? It is ax minus bx. Ax, this ax. Ax is this one, 14 meters. Bx is minus 15 meters. So ax minus bx is equals to 14 meters minus, then another minus 15 meters. 14 meters minus 15 meters, that is going to give you 29 meters. Is that clear?
Yes, sir.
Next, we move on to this one, ay. So in the y component, it's going to be ay minus by. So ay is 14 meters, by is 26 meters. So here we are working out 14 meters minus 26 meters, and this gives us minus 12 meters. So we can see one thing here. The x component of ax, of a minus b, is positive. So this bit points along the positive part of the xy plane. This other bit, it's pointing in the negative direction of the y-axis. So in the negative y-axis. That's why there's a negative there. So if there's a negative, it tells you it's pointing in the negative part of the axis. In this case, the y-axis. If it's positive, it's pointing in the positive part. Then you have this one here, b minus a. This is another calculation, b minus a, and we need to find out how much b minus a is along the x-axis and how much b minus a is along the y-axis. So for us to find out how much b minus a is along the x-axis, we know that b is minus 15, then a is 14. So this is going to be, b minus a is going to be minus 15 minus 14 meters, and that's going to give us minus 29 meters. So in this case, the x component of b minus a is pointing along the negative x-axis and has got a size of 29 meters. For the y part, we have by minus ay. So the by is 26 meters, the ay is 14 meters. So this is going to be 26 meters minus 14 meters, and that gives you 12 meters. So the y component in this case is pointing along the positive y-axis. So here for b minus a, the x component is pointing along the negative x-axis. The y component is pointing along the positive x-axis. That's what these numbers are telling you. If the component is positive, then it's pointing along the positive end. If it's negative, it's pointing on the negative end. Then you have this one, a plus b plus c. So we want to find out how much this is along the x-axis and how much it is along the y-axis. So we are going to add the components ax plus bx plus cx. Ax is 14 meters, bx is minus 15 meters, cx is minus 10 meters. So it's going to be 14 meters plus minus 15 meters plus minus 10 meters, and that's going to give you minus 11 meters. So the x component of a plus b plus c is negative, telling you that it's pointing along the negative x-axis and has a size of 11. The y component of this a plus b plus c, we get that by adding ay plus by plus cy. So ay, we know ay is 14 meters, by is 26 meters, cy is 0 meters. So ay 26 meters plus by, ay 14 meters plus by 26 meters plus cy 0 meters, you get yourself 40 meters. So the y component of this vector a plus b plus c is 40 meters. Are we clear? So you keep on adding the components of these vectors you have worked out. It doesn't matter how many vectors you have, you add their components. This one, a plus b minus c. How much is this a plus b minus c along the x-axis? It's going to be ax plus bx minus cx. So ax is 14 meters, bx is minus 15 meters, cx is minus 9 meters. So here we're going to have 14 meters plus minus 15 meters minus 10, and that's going to, you're going to end up with 9 meters. So here we have the x component being equals to 9 meters, and it's positive, so it's pointing along the positive x-axis. Then ay plus by, then this side, the y component, it's going to be ay plus by plus cy. So how much is ay? Ay is 14 meters. Then your by is 26 meters. Then your cy is 0 meters. So here we have 26 meters plus, 14 meters plus 26 meters minus 0 meters, and that gives you 40 meters. So in this case, both the x-axis is positive. The x component is positive of a plus b minus c is positive, and the y component of a plus b minus c is also positive. So both components are positive in this case, similar to what we have up there. Are we clear? So these are these a plus b, a minus b, b minus a plus b plus c, a plus b minus c. These are what we call the resultant. Okay, these are what we call the resultant. For each of these vectors, using this table, we know how much each of these resultant is along the x-axis. We know how much it is along the y-axis. We also know the directions in which these vectors are pointing. Is that clear? For a plus b, the x component, this x component is pointing in the negative direction and the size of 1. The y component is pointing in the positive direction and has got a size of 40 meters. So we can get this information and we put it on an xy plane so that we find out in which direction. Sorry?
I have a question, sir.
Yes.
Where do you find the resultant vectors after adding? Since, for example, there is negative 11, which direction does it point to?
Negative 11. Which negative 11?
Yeah,
This one?
Negative.
Negative 11, this one?
The one we found when we added the x, ax, bx, yeah, that one.
Yes. This one is negative, but the direction is the x. So it's pointing in the negative direction of x. It's pointing in the negative x direction. Remember, it's under this.
All right, okay.
Under the x component. So if it's negative, it's telling you it's pointing in the negative x direction. If it's positive, it's telling you it's pointing in the positive direction of x. There is a column here. So everything under here, under this column, is talking about the x direction. Everything under this column here is about the y direction, whether it's pointing in the positive or in the negative part. So in this case, for this one is pointing in the negative x direction. This one here is pointing in the positive x direction. This one is pointing in the negative x direction. This one is pointing in the negative x direction. This one is pointing in the positive x direction. Here, this one is pointing in the positive y direction. This one is pointing in the negative y direction. This one is pointing in the positive y direction. This one is in the positive y direction. This one is the positive y direction. So for each resultant, we know how much each of these things is along the x direction and how much it is along the y direction. Are there any questions before we move forward?
Yes, is that the way we display the answer?
This is a step which needs to be done. We have not yet found the answer because the answer needs a size of the vector. It also needs an angle. We haven't found those, but this is an intermediate step to finding the answer. So this step needs to be carried out. You need to know how much the resultant is along the x direction and how much the resultant is along the y direction. You need to know these. Once, for example, let's start with a plus b. We know along the x direction, a plus b is minus 1 meters. And a plus b along the y direction is 40 meters. Then, those are the components, the x components and the y components of a plus b. So we can proceed to find the size of a plus b using this formula here. The size of a plus b, the magnitude of a plus b, which we can write like this, is going to be equals to the square root of ax plus bx squared plus ay plus by squared. Ax plus bx. This we know from here. Ax plus bx here. Ax plus bx is minus 1 meters. Then ay plus by, that is 40. So when we get those, we put them in this formula, we can start working out things. So here, so this bit is minus 1 meter, so we square that, plus the 40 meters, we square that. So when you square this whole thing, so the thing inside is going to give you 1,601 meters squared. Then do the square root, so you end up with ax plus bx approximately having a size of 40 meters. So you have found the magnitude of a plus b. A plus b has a size of 40 meters. Is that clear?
Yes.
The next step is you need to plot this ax plus bx on the xy plane and ay plus by. So we plot this one, we know is minus 1 meters along the negative x-axis and the 40 meters along the positive x-axis or positive y-axis. So you plot them, and that's what we have here. Ax plus bx, this one here, down here, it's negative. So down along this line, that's a negative 1 meters. Then along the y-axis, if you plot it, that is ay plus by, you have 40 meters. So along the x-axis, negative x-axis, you have your 1 meter. Along the y-axis, you have your 40 meters. The next thing you do is you get this one on the y, this one on the y, okay? you shift it so that it starts from the end of this one. So you move like this. You move this way along the x-axis, then you move up like that. Can you see along this dotted line?
Yes.
Yes, it is the same thing.
Yes, sir.
Because, why do we say it's the same thing? Because the length of this line is 40 meters. That's what we think, it's 40 meters. And the direction is the same because it's parallel to this. It's parallel to the y-axis. So as long as the size is the same and the direction is the same, then we are talking about the same vector. Remember, a component is just how much a vector is along a particular direction. So the x component, you move along the x component like this, then you move along the y component like that. So you're going to end up here at that particular dot. You started from here, then you end up there. That is the same as moving along this green line. Have you seen that? If you move this way, -1 meters this side, then you move 40 meters up there, that is the same as moving along this green line. Is that clear?
Yes, that
Yes,
is clear.
sir. Yes, sir.
This green line is what you call A plus B, the resultant. That's a green line, A plus B. Are we clear? This green line is the resultant A plus B. So that's how you find the resultant in a picture way. And we have already worked out what the size is. The size of this resultant A plus B is 40 meters. So what is needed now is what is the angle this vector makes with the positive x-axis. Yes?
Hello?
Yes? Go ahead.
I have a question.
Yes.
The vector A plus B is how have you found the angle for the vector A plus B?
We are looking for that angle. We haven't found it yet.
Oh, alright.
Yeah, we have just found the size of A plus B. From up here, we have just found the size of A plus B. That A plus B has a size of 40 meters. So we are looking for the angle now. That's why we are making this plot. We are making this plot so that we can have a rough idea of where A plus B is.
Alright, sir.
Yes. So the next thing, as our friend was asking, is how do we find the angle A plus B makes with the x-axis? And that angle is this one. From the positive x-axis, there, that angle, this theta. How do we find this theta? Okay. How do we find this theta? Is there a question?
Yes, sir.
Yes.
Yes, what if the size of A plus B wasn't the same as A plus B? On the
What? What is what?
What if the size of A plus B?
No. We're not going to do what if here. What we have is this. So we're going to see how to add this based on that table. You can try to do the what if stuff later on, but for now the focus is here. We want to see how
No,
we.
there's no point where you can find it's lesser than the other.
Which one?
Like it's not 40 meters. This you found the size to be 40 meters, and then AY plus BY as well 40 meters. What if AY plus BY was not 40 meters?
It can be anything, Anga. I don't really care very much, Anga. It just turns out that it's 40 meters.
Alright.
Yeah, I don't care very much about that. It just turns out that it's 40 meters, that's all. It could be more than 40 meters or less than 40 meters, depending on whatever vectors we chose. Okay?
Yes, sir.
Yeah. So,
Sir, I also have a question.
yes.
Like on finding the components of this A and B to find the result, and which figure did you use? Is it the place quadrant to the one which is there.
We are trying to work out that. I don't know why you're going ahead of everybody else. That's what you're trying to work out. Okay, so as you can see, the angle we want is this one, this theta. Okay, this theta, that's the one we're looking for. This other angle is what is called phi. Now, for us to find this angle, we know these two angles are related because theta plus this angle, that gives us 180. So these angles, theta plus phi, are related. The way where our vector is, you can see if I move this way, this is my a plus b. Then you can take this a plus b to be your hypotenuse. If you can take this to be a hypotenuse, then this other one, the dotted line here, you can take this to be your opposite. Okay? Then this one at the bottom here, you can take it to be your adjacent. So basically what you have here is a triangle. This. Can you see that? Where the a plus b, the resultant is the hypotenuse, then this one, ay plus by, is the opposite, then ax plus bx is the adjacent. Can you see this? That we have a triangle here with hypotenuse 40 meters, the opposite 40 meters, the adjacent minus 1 meter. Is that clear?
Yes, sir.
So, if we have a triangle like this, what we are going to work out using that tan formula, the tan of the y component divided by the x component, what we are going to work out using that formula is this angle inside the triangle. Okay? Once we find the angle inside the triangle, we can use the angle inside the triangle to find theta, because these two angles are related. Phi plus theta gives you 180 degrees, or whatever. This one here is 180 degrees. The negative x-axis is 180 degrees. Then you subtract, you remove, you add phi to it. Then phi is going to take you backwards because phi is going to come out negative. So 180 degrees plus phi is going to give you theta. So let's see. So what we're going to do, because of this triangle thing business we're getting here, what we're going to work out is this phi and not theta. So we're going to work out phi using that formula, the tan formula. Then after we find the phi, then we're going to find theta. Is that clear? So here, tan phi is equals to ay plus by, which is the y component, the one you put on top, divided by ax plus bx at the bottom. So ay plus by is, the ay plus by is this, the 40 meters, divided by ax plus bx with the 1 meter. So ay plus by, so that goes on top, 40 meters, so tan phi 40 meters divided by negative 1 meter. So we end up with the meters, they cancel out, we end up with minus 40. Then for us to get this phi angle, so we get the inverse of the tangent. So phi is going to be the inverse of minus 40. This is going to give you an angle which is equals to minus 89 degrees. Is this clear? So we get a phi which is equals to minus 89 degrees. So basically what this means is we from 180 degrees we move backwards like that by 89 degrees. Minus 89 degrees. So how do we get our theta from this then? So our theta is going to be equals to 180 degrees. This one 180 degrees plus phi. So that's going to be 180 degrees plus phi, which is minus 89 degrees, and this gives us a theta which is equals to 91 degrees. Are we clear? The angle inside the triangle, we need it. This angle inside the triangle, which we are calling phi, that is what we can work out using that tangent formula. Tan phi equals to the x component of the resultant, or equals to the y component of the resultant divided by the x component of the resultant. We work out what phi is. Now, depending on where you are along where the vector is in the xy plane, your phi can be positive, your phi can be negative or positive, negative or positive, okay? Or phi can be equal to theta, especially in the first quadrant here. In the first quadrant, your phi is equal to theta. This theta is measured from always measured from the positive x-axis, then you move in an anti-clockwise direction. This phi is the angle of the triangle you form when you use your x component and your y component, then the hypotenuse. This triangle you're forming, its angle, that is what is phi. These two angles, they are different quantities, but they are related. Phi plus theta, you get 180 degrees. So for you to get theta, you add to 180 degrees, then you move back in reverse like that, then you get your theta. Are we clear?
Yes.
Next, so we have seen how to find, so now we know something about A plus B. A plus B has a size of 40 meters, and the angle it makes from the positive x-axis from here, it's 91 degrees. Clearly what I've drawn here doesn't look like 91 degrees. So what I've drawn here is, as you can see, an over-exaggeration of reality. But that doesn't matter because you have found exactly what the angle is. It's 91 degrees and the resultant has got a size of 40 degrees. Next, we move on to A minus B. So we need to work out two examples, A plus B and A minus B. Then the rest of them, we can finish them up tomorrow. So A minus B. So we know A minus B, here we are, A minus B. A minus B along the x-axis, A minus B has a size of 29 meters. And along the y-axis, A minus B has a size of minus 12. So along the x-axis, A minus B points along the positive x-axis, and along the y-axis, it points in the negative direction. So what is that one? Here it is. So A minus B, AX minus BX, along the x-axis, this line is 29 meters. That line, A minus B, 29 meters along the x-axis. Then along the y-axis, A minus B, it's minus 12 meters. So it's pointing down like this. It's pointing down in the negative y direction. So this is how you plot your components. If it's positive, you draw it along the positive part of the xy plane and you give it a size. If it's negative, like in this case, you make it point in the negative direction and you give it a size. We do the same thing we did earlier, okay? So in this case, we get this negative bit, we put it at the end of the x component so that we end up moving like this. Then we move along the dotted line like that. We haven't changed anything because it's still AY minus BY, which is minus 12, because the size we are moving along the y-axis is minus 12 and the direction is parallel to the y-axis. So we haven't changed anything. So if we do this, we move along this direction, along the x-axis, we move 29 meters, then we move minus 12 meters parallel to the y-axis like this, we end up here. So if you move this way, then we move like that. This is the same as moving along this green line here. If you move along this green line here and you end up there, this is what your A minus B is. A minus B is this green line. Is that clear?
Yes, sir.
That's A minus B. So A minus B is in the fourth quadrant of your XY plane. Okay. So we have an idea of where A minus B is. The next thing we need to do is we need to find the size of A minus B. Then we need to find the angle A minus B makes with the positive x-axis measured anti-clockwise. Okay, so this is the x component minus 29, where the y component is minus 12. So the size of a minus b. So the magnitude of a minus b, written as this, is going to be like this, is going to be the square root of ax minus bx. The x part is 29 meters squared plus ay minus by squared. So this bit is the 29 meters you're seeing here. Then the other one, ay minus by, is the minus 12 meters you are seeing there. We square this 12 meters squared plus minus 12 meters, 29 meters squared, then brackets minus 12 meters squared, you end up with 589. Then you square root this, you end up with basically a magnitude of approximately 31.4 meters. So A minus B has a magnitude of 31.4 meters. Is this clear to anyone? To everyone? On how we are finding the size? Is it clear?
We are there.
Okay. So you use the components of the resultant. The x component of a minus b is 29 meters. The y component of a minus b minus 12 meters. Then you put them in this Pythagoras formula. Okay, where these are the x components squared plus that's the y component squared. Then you get your size. So we have a size of for a minus b, that is 31.4 meters. Okay. Next is the direction. We need to find the direction. The direction we are interested in when it comes to a minus b is the angle from this positive x-axis. From the positive x-axis, we move anti-clockwise like that until we meet this a minus b in the fourth quadrant. So the angle we are interested in is the theta, the angle outside, this angle, theta. We always want theta. The angle outside, that's a theta. Then, if you create a triangle, this triangle, if you create this triangle, where this end is your adjacent, then this one is your opposite, then this one is your hypotenuse, you have this angle inside the triangle. This angle of the triangle is your phi. And you can see there's a relationship between theta and phi, because if you cover this much distance, theta, then you add your phi, you end up with 360. So theta plus phi gives you 360. Is that clear? Is that clear?
Yes, sir.
Yes, sir.
Yeah, so we're going to use the fact that theta plus phi gives us 360 to find theta, because with this triangle, what we can work out with this information we have for the resultant, the x component 29 meters, the y component minus 12 meters, what we can work out with this triangle is the tangent. Using the tangent of phi, we find phi by working out the tangent. That's what we can work out using the 29 meters and the minus 12 meters. We work out phi. Then after we find phi, we are going to add this phi to 360 degrees so that we can get theta. So when we do that, here, tan phi is equals to the y component of a minus b. The y component is this one, ay minus by minus 12. So ay minus by, then divided by the x component, which is the 29 meters, ax minus bx. So ay minus by, that is minus 12 meters divided by 29 meters. So the meters, they cancel out, we end up with minus 0.41. Then we work out the arctangent of this, so we get phi. So phi is equal to the arctangent of minus 0.41, and we get an angle which is phi is approximately equals to minus 22.3 degrees. That's how much phi is. Phi is an angle and it's minus 22.3 degrees. So far our phi's have been negative. Okay. So how do we get our theta? So our theta, we get theta is equals to 360 degrees plus phi. That is equal to 360 degrees plus minus 22.3 degrees, and you end up with a theta which is equals to 337.7 degrees. So from this end, from the positive x-axis, for you to reach this a minus b, you go 90, 180, 270, then it's 337 degrees. That's how we get this position here. Is that clear?
I have a question.
Yes.
Is it possible to have an angle?
Ati? Is it possible to do what?
I'm asking, you said it's about direction. What's the direction of this angle, or this vector?
The direction. Now, there are some people, I don't know whether they're asking questions or they're just moving around their chairs. I don't know who is asking the question. Because there are some people who are not asking questions. Okay, so that Jethro, why is your microphone on?
I was asking about the direction. What's the direction of that vector, sir?
The direction is here. The direction is 300 and that's what you found here. This is the angle I found. This is the direction. The direction, the angle is always measured anti-clockwise from the positive x-axis. This way, we call this way, anti-clockwise. Always. Angles are measured anti-clockwise. So there's this angle theta, which is we're measuring anti-clockwise. Then there's something inside here, this angle phi, which is the angle of the triangle. This one is a negative angle. We do not use phi to give direction. We use theta. So whatever we work out phi, then we know that there's a relationship between theta and phi, because both these angles, if you add theta plus phi, they give you 360 degrees. So always direction is measured from the positive x-axis, then we go anti-clockwise. Always. Are we clear? You measure direction from the positive x-axis, then you go in an anti-clockwise direction. So this 300 and something, this is 337 degrees anti-clockwise from the positive x direction. Is that clear?
Yes, sir.
Any other question?
Yes, sir.
Hello?
It's negative 20,
Ati?
2.3 degrees. Is it possible to have a degrees or negative degree angle?
A negative degree angle. Oh, we choose direction. Yes, that's a good question, Anga. What does it mean when you have a negative angle? We choose direction from angles. Angles, you can go this way or you can go this way. So there are two ways you can go when it comes to an angle. You can go clockwise or you can go anti-clockwise. In physics, we measure angles in an anti-clockwise direction. So that anti-clockwise direction is the positive direction. So if you see a negative angle, it means that you are going in a clockwise direction. You're going this way. You're going like that. From the positive x-axis, you go under the positive x-axis like this. That's what it means when you have a negative angle. That's why we are starting from here, then we're going this way. That's why we are doing 360 degrees plus whatever the angle is, because the angle turns out to be negative. That's how we end up with this. Previously, we were adding 180 degrees. It was negative here. So 180 degrees. Then it's negative. So it means we start from here, this end, then we go this way. Okay, we start from this end, then you go that way. These two angles are measured differently. The angle of the triangle phi is measured from the nearest x-axis. That nearest x-axis can be this one, like in this case. This phi, you measure it from the nearest x-axis. So it can be this one, or it can be that one, depending on where you are. So if you're measuring it from here, then you're moving in this direction, it's going to be negative. If you're measuring it from here, then you're moving in that direction, it's going to be positive, because angles measured in an anti-clockwise direction are positive, and angles measured in a clockwise direction are negative. Does that answer the question?
Yes, sir.
Yes, it's because we chose to say all positive angles are going to move in an anti-clockwise direction. So if an angle is moving in a clockwise direction, it's going to have a negative sign. And this phi, as you can see, from here, from this line, from the x-axis, is going that way. That's anti-clockwise. That's why it's negative. Here, the phi, we are measuring from the x-axis. It's going this way. It's negative. It's moving in a clockwise direction. That's why the angle comes out negative. But if you were if your angle was this side, if you move from here to this side as your angle of a triangle, if you in this side you're moving in a anti-clockwise direction, so your phi is going to come out positive, because you measure your phi from the nearest x-axis, whether it's this one or that one. But theta is always measured from the positive x-axis. Theta always from the positive x-axis, anti-clockwise, so that theta always has a positive, is always a positive angle. Theta is always a positive angle. Phi, which is the angle of the triangle, depending on which axis you're using and depending on whether the vector is up here or below here, it can have positive or negative. Then you're going to add things accordingly. Are we clear?
Yes, I'm very clear.
Okay, so today we're going to end here. Tomorrow when we meet, we are going to finish up the last three questions. So that is B minus A plus B plus C, then A plus B minus C. So we're going to do those ones tomorrow. Unless there are any questions, we end here. I'll stop sharing my screen and I'll stop the recording.